Well, good day, everybody. This is Chris back again with the Ancient Scholar, and this is, I believe this is video 5 in a series of videos on receptors. So now what I'm going to do, now that we've kind of laid the foundation, is I want to go ahead and I want to focus on the parasympathetic nervous system, the P-A-R-A, parasympathetic. The parasympathetic nervous system, and I want to focus in on the nicotinic and the muscarinic receptors. And before I do that, let me just throw out a term, and the term is known as cholinergic. All right, cholinergic. And a cholinergic receptor. A cholinergic receptor is a receptor that is acted upon by a very specific molecule, and that molecule is known as acetylcholine, and people often call this ACH. So anytime I talk about a cholinergic receptor, any cholinergic receptor is a receptor that can be acted upon by the neurotransmitter acetylcholine. Okay, this includes nicotinic and muscarinic receptors. Okay, nicotinic and muscarinic receptors are both receptors that are acted upon by acetylcholine. So most of the receptors of the parasympathetic nervous system are cholinergic receptors. Okay, cholinergic is just a broad term that means that that particular receptor is acted upon by the molecule acetylcholine. And acetylcholine is a neurotransmitter. It's produced in the neuron, and acetylcholine has kind of the basic chemical structure is it kind of looks like this. H, so carbon, and you can imagine that I have three hydrogens coming off this carbon. That's H3. So it'll look something like this, and then I have a double covalent bond to an oxygen here, and then a single bond to an oxygen here, and of course I have hydrogens coming off of all that. I really won't draw those in. I keep doing that, and then something like this, and then it goes to a nitrogen, and then I have 3 methyl groups that come off of the nitrogen, 3CH3CH3. Okay, we call this part here the acetyl part, and it actually comes, this acetyl group comes from acetic acid, and then this part here is the choline. Okay, so that's the acetylcholine molecule, and the acetylcholine molecule is able to act upon nicotinic and muscarinic receptors, and of course we know we have a whole bunch of these in the parasympathetic nervous system. Okay, so now let's just talk a little bit about kind of the difference between muscarinic and nicotinic receptors, and again I'm going to try to keep this a big picture if I can. So muscarinic, and the nicotinic. Now these are both cholinergic receptors, that is to say that acetylcholine acts upon them, and we find these in great quantities within the parasympathetic branch of the peripheral nervous system. Okay, so muscarinic receptors are interesting. Muscarinic receptors, we first identified these because they they tended to associate themselves with, or they were, I should say, sensitive to something called a substance called muscarine. Muscarine. Now, muscarine is not produced by the human body. It is synthetically. It is a synthetic compound that's produced. Is not produced by the body, but that's how we found these. That's how we first found these receptors, and so that's why they're called muscarinic. It doesn't really have anything to do with any molecule within the human body. It just has to do with, well, that's how we found them, is that this molecule muscarine they were sensitive to it, even though the body doesn't produce it. A lot of cases, that's how things get their names in physics, chemistry, and biochemistry, and the name doesn't really have anything to do with whatever we're talking about does in real life. Okay, so it's these names are more historical, I suppose, if you want to look at it that way. But anyway, muscarinic receptors belong to if you remember, when we were talking about the metabotropic and the ionotropic, the muscarinic receptors belong to that class of receptors known as metabotropic receptors. Specifically, they involve the G protein, a G protein linked pathway within the cell. Okay, so the muscarinic receptors, like we talked about in the last video, their effects tend to kind of revolve around glands and secretions, and increased mucus and increased gastric acid secretion and so on. And the way they do that is through the G protein coupled or linked pathway within the cell, and these work because the neurotransmitter acetylcholine acts upon them. Okay, now the nicotinic receptors are very different. Now it is still acetylcholine. Okay, I want you guys to be very clear here. It is still acetylcholine that acts upon these receptors. Okay, but the physiology is very different. Nicotinic receptors happen to they happen to be more sensitive to the substance nicotine, and again, it's not as relevant biologically in our body, and we know that really it's acetylcholine in the body that acts upon them. But again, this is more historic. That's just kind of how we identified them as, the nicotinic receptors tend to be sensitive to nicotine, the muscarinic tend to be sensitive to muscarine. But we know that it's really that the neurotransmitter from the nervous system, the neurotransmitter acetylcholine, is what's really acting upon these. Okay, now the nicotinic receptors are not metabotropic; they are ionotropic. Okay, they are ionotropic, and so they are the ligand. Okay, ligand gated. Okay, they are ligand gated ion channels. Okay, so it's kind of important that when we talk about nicotinic receptors, these are often located in muscle tissue, and so when these are acted upon, they open up and they allow sodium, particularly sodium, to flow into the cell, into the muscle cell, for example, and that causes the muscle cell to depolarize, which can then lead to muscular contraction. Okay, and then that can lead to, let's say, smooth muscle in our lung contracting and our bronchioles narrowing. Okay, that's one of the mechanisms that can cause bronchospasm, is the activation of nicotinic receptors and smooth muscles in the lung. If I have the somatic nervous system, because the somatic nervous system goes to nicotinic receptors on skeletal muscle instead of smooth muscle, and I can have muscular contraction, right? So the nicotinic receptors open up when they're activated, sodium rushes in, the muscle depolarizes, the muscle contracts, and that leads to muscular contraction. Okay, so it's very important to understand the differences between these receptors because they really do have very different physiological effects. So just remember that both, while they do have different physiological effects, they are both activated by acetylcholine, and any receptor that is acted upon by acetylcholine is still known as a cholinergic receptor. Okay, so even though nicotinic receptors are ionotropic ligand-gated ion channels, they are still cholinergic because acetylcholine acts upon them. Muscarinic receptors, even though they're metabotropic and G protein linked, are still cholinergic because acetylcholine acts upon them. Okay, guys, I'm going to cut it off here, and then we'll talk about the sympathetic receptors in the next video. As always, thanks for hanging in there.